Okay. Okay. Thank you, Sharon, for that nice intro. And I guess the first correction I'd like to make is when I wrote this bio, I was the president. I'm now the past president as of November, so sorry if that's disappointing. It's a year term, and my term was up in November. So today I'd like to talk a bit about sound quality in the audio industry, and I'm going to really lean on our own research in our group, and I'd like to give credit to my colleagues Todd Welty on the left as well as Elizabeth McMullen. So if we look at audio, I guess since the 1990s, late 1990s, there were some key factors, I think, or catalysts that had an impact on the quality of audio. One of them, of course, there was wide adoption of digital technology. The iPod was invented in the early 2000. More and more people became connected to the internet, and mobile phones later on became widely available. And in order to transmit audio over these communication networks, it had to be compressed or reduced in size. So immediately we had, in order to fit 1,000 songs on your iPod, you had to use some kind of lossy compression. And that had implications on the sound quality. The other thing was more and more people wanted to carry audio with them. Rather than carry their CDs around, they wanted to have it on their phones, on their iPods. So the playback devices became smaller, the speakers became smaller. It had to fit in your pocket. So it became smaller, lower costs, and battery power became a factor. So the sound quality wouldn't play as loud. There was generally higher distortion, and there was an absence of bass, and the real cost factor meant that a lot of these devices were manufactured in the Far East, and there wasn't a lot of engineering involved. And then with that, people wanted to have portable playback devices, so speaker docks, very small speaker docks, wireless speakers, and then headphones became very popular. I thought I'd never see a resurgence in headphones in the late 80s. I thought people would always listen to speakers, but sure enough, headphones became very popular, and at the same time they became fashion items. So instead of making them sound good, it was more important that they look good. And then another factor, in the late 1900s, a lot of audio retailers closed shop as retail sort of went to the internet to companies like Amazon. So consumers no longer had the opportunity to go into a brick and mortar store and hear a demonstration of 3 or 4 different speakers. Increasingly today, more and more people buy audio devices without even listening to them. So this means it becomes increasingly important that the specifications that come with the product are really meaningful in terms of how it sounds. And unfortunately, right now, we're not at that point yet. And then in parallel, not only did the playback devices get worse, and of course the compression meant that there was a loss in quality, but the recording industry went through this period of time where they would compress the dynamic range of audio. So this is pretty well documented. Over the last 10, 15 years, the effective dynamic range in music has been greatly reduced to the point where there may be effectively more dynamic range in a vinyl record. So the reason people are going back to vinyl, I think one of the reasons is it's not as dynamically compressed. And I think a lot of this had to do with once you had songs being sold as singles on iTunes, people were carrying around playlists in their pocket, and there was a real marketing demand to have your song to be as loud as the loudest song on the playlist. So recording artists, producers began dynamically compressing their music, and that led to a loss in quality. In terms of the marketing business mindset at this time, the real driving factors were portability, convenience, and cost. And a lot of marketing departments, certainly in my career, have always argued that sound quality is something that you can throw away because it's very subjective. It's a metric that it involves human perception, and it's very difficult to measure accurately and reliably, so it's easy to ignore it when you're selling it as a feature. And the other thing I've heard in the last few years is that preference in sound quality, much like wine, food, is very dependent on the individual. So your taste in sound quality may depend on age, experience, or even your culture. So there's this notion within marketing departments that we may want to design a speaker or a headphone differently for an Asian market compared to a North American market or a European market. And this is something that I've looked into in the last few years. So around 2010, there we go. So around 2010, there was a lot of press about the state of audio. The New York Times said in a mobile age, sound quality takes a step backwards. And then in Wired magazine, there was a really, an article that got a lot of attention called the Good Enough Revolution, and that's where my title came from. This was a term that Wired came up with, which basically said that consumers, as long as it's portable, cheap and simple to use, and it's good enough, it doesn't have to sound any better. And then there was this interesting article in the New York Times where there was a professor at Stanford University named Jonathan Berger who over the years had been doing listening tests, informal listening tests in his class, and he found more and more students preferred lower quality compressed audio over the original CD lossless version. And his theory was that people, as they become exposed to bad sound, it in fact becomes their reference and they actually prefer it. And this was reported as fact, you know, in the New York Times. And when I contacted the professor, there was no response. And it turned out that there was never any published work that really backed this up. And, but I was getting a lot of input or questions from marketing departments saying, and even customers, do we really need to put 17 speakers in our automobiles when the evidence, quote evidence, suggests that especially younger demographics prefer lower quality sound. So this led to some research because there really hadn't been any published research. And my first experiment was involving testing the preferences of young people. And it wasn't a very big experiment. It involved having local colleges come to our laboratories in Los Angeles, and we had high school students as well as college students, and they all had different levels of experience in judging sound quality. So we had high school students, we had university students studying sound recording at Loyola Marymount with some experience. We had graduate students from UC Irvine who were doing their masters in sound design for theater, and they actually had some listening experience, formal listening experience. And then we had some visual arts students from Cal Arts who had a sort of an interest in audio. And if you've followed any of our research, you'll find that we try to do very rigorous listening tests. They're always double-blind. We do level matching. We train our listeners in general, but in this case, these are all what we'd call untrained listeners. And we did an experiment where we presented music selections that were the original CD version, and then we did a low-quality MP3 version, which was at the same bit rate as what Professor Berger had used at Stanford. It was 128 kilobits per second. And the listeners basically were presented either A or B, and they had to simply say what is their preferred choice. When we looked at the results, we found that as a function of these different groups, we found that 86% of the UC Irvine students preferred CD over the MP3 version. So in 86% of the trials, they chose CD as their preference. The Loyola Marymount students picked CD 72% of the time, high school students 67%, and the CalArts students 63%. And if you look in terms of their listening experience, there's a clear correlation between the amount of experience they have in doing formal listening and the percentage of times they chose CD. If you look at the individual listeners, all 58 listeners, you found that none of them had a statistically significant preference for the lower quality MP3. In fact, most of them were either guessing or they were above the 50% rate where they're choosing CDs. So we found no evidence, contrary to what the New York Times was reporting, that these young students preferred the sound of MP3 over CD. In fact, it was quite the opposite. So the next thing we asked them was, we were curious whether they preferred accurate neutral loudspeakers given the choice of a neutral speaker over a less neutral one. And we included, again, high school students, college students. We also had some visiting students from Japan who spoke no English, but we had translators. And we were interested in what they preferred because at the time we were getting questions from some of our Japanese customers questioning whether we should tune our cars differently for the Japanese taste versus the American taste. And then all of these untrained people were compared to the preferences of our trained listeners that we have on staff. So the speakers included 4 different models, ranging in price from $500 to $3,800. And one of the things I found over my career is that price doesn't always correlate to better sound. And in our labs, we have a very elaborate room where we have a pneumatic floor that automatically shifts each speaker into the same position so that the speaker is basically exciting the same resonances of the room because they're in the same position. So the room is being excited the same so that the differences in sound at the listener's ears are strictly related to the loudspeakers and not their position in the room. And of course, we have a curtain that comes down, so it's a double-blind test. The listener's not aware of what's behind the curtain, and the computer completely controls the test. So what we found, these are the results of these different listening groups. And these are the results from the high school students. You can see they prefer loudspeaker A. The first set of Japanese students, the second set of Japanese students, the CalArts students, the Loyola Marymount students, and then finally we show the results of the trained listeners from Harman. And this is a typical set of data that we see when we compare trained listeners with untrained listeners. The trained listeners tend to rate things higher on the preference scale than the trained listeners, but the overall order of preference is very much the same. So regardless of whether a listener's trained, untrained, from Japan or from America, they prefer the same loudspeakers. The main difference with a trained listener is that they're much more discriminating and they're much more reliable. So you don't have to use as many listeners when they're trained to get the same statistical confidence. And this next slide, I won't go into detail about what these measurements, how we derive these measurements, but you can see the mean preference ratings, the blue bars, and above we show some anechoic measurements that we do routinely for each loudspeaker. And if you just visually look at those curves, you can see that the ones that are preferred tend to be very wide in frequency response in terms of bandwidth, so they produce the lowest notes and the highest notes. The top couple of curves represent the direct sound, the first sound that arrives at the listeners. And as you move down, those are the off-axis curves. So it tells us that the direct sound is important, but also the reflected sounds are very important as well in determining your preference and what you perceive. And as those curves deviate from flat and smooth, to something like speaker B. You can see it looks like a smiley face, so it has sort of emphasis in the bass and treble, but it's not very neutral. Speaker C has elevated mid-range and high frequency relative to the bass. And speaker D, which happens to be the most expensive speaker, you can see it's not very flat. It's full of resonances, and it's adding colorations to the sound. So again, here is more evidence that what listeners prefer in a loudspeaker is a very neutral, accurate sound. They don't like colorations added to the sound. So we concluded from this study that college students can indeed discern and prefer higher quality lossless audio over the MP3 versions. And when given the opportunity to compare neutral loudspeakers with less neutral ones, they chose the higher quality versions. And we found that the training of the listener or their experience is not that important. Even untrained listeners can recognize good sounds. The trained listeners are simply more discriminating and repeatable. So in the last 2 years, we've done a lot of research on headphones because, as I said, sales now, I think, are projected to be close to 10 billion worldwide. So it's a category that's really come on strong. And yet, when you look in the scientific literature, there hasn't been a lot of research done in 20 or 30 years. So what research has been done on headphones, you can find a few standards that haven't involved many listening tests. So a lot of the knowledge is not really based on hard, good controlled listening tests. And what they have come up with is two recommended calibrations, which are referred to as diffuse and free field. And the main reason I believe that people haven't reported results based on listening tests is they're really hard to do. I mean, loudspeakers are hard enough to compare blindly, but it's very difficult to do a blind comparison of a headphone because you can feel it, you know it's on your head, you can tell the weight, the pressure on your ears, plus you can see it unless you're blindfolded. So these tests are rather challenging. So if you're interested in what we've done, these papers are all available in the Audio Engineering Society as preprints. And I'm just going to summarize 2 or 3 of them. The first one we did was basically ask this general question: do people agree on what makes a headphone sound good? And we selected 7 popular headphones ranging in price from $100 up to about $1,000. And they were all, some of them included very popular models in terms of the marketplace. And we came up with this methodology where the subject would come into a room and an administrator would substitute the phones from behind. So the listener wasn't aware of which headphones they were listening to, so we've controlled the visual factors and the brand and the price and the celebrity endorsement effect, but the listener's still aware of the tactile cues. So after doing several trials, they become aware that this is the same headphone I gave a 5 out of 10 last time because it has a high force on my head. And here are the results of the subjective results. These are the preference ratings, and above are some acoustic measurements of these headphones. Shown in red and black as the left and right channels. These dotted green curves below each graph represent the subject's perceived spectral balance of the headphones. So in general, the headphones that were perceived to be neutral tended to have flat lines. These green lines were more or less flat. And as the headphones have bumps in them, they're telling us they have too much bass in the case of headphone 3. Headphone 4, they're saying there's not enough bass, and headphone 5 and 6 are really not very neutral, as suggested by the subjective graphs as well as the acoustical measurements. So it was very encouraging First of all, that the listeners generally agreed what headphones sounded best, and these subjective measurements tended to correlate with the objective measurements. But the other thing we found right away was that there was some disagreement for certain models of headphones between listeners. And we looked into this a little farther, and we found that it was how well the headphone fit the listener affected how much leakage there was. And the more leakage the headphone had, the less bass there was. So some listeners, if they had a good fit, said this headphone sounds great. It has maybe a bit too much bass. If it didn't fit another listener, they would say it sounded thin in the bass. So we found early on that the fit is a real critical factor, and it's a variable that you have to control whether you do objective or subjective measurements. So the next set of experiments, we looked at the literature. There were these two standards referred to as diffuse and free field, and we found that we had a theory that perhaps these standards are not ideal because the diffuse field calibration assumes that if you put a listener, if you put a headphone on a listener, what you measure at the eardrum should be what you would measure from speakers in a diffuse field. And the free field calibration assumes that the listener, you put a listener in an anechoic chamber, you measure at the eardrum the loudspeaker transfer response, and they're saying that's what the headphone should duplicate. And we believe that that was a flawed premise because typical rooms are neither diffuse nor free field, but they're somewhere in between where you have a very strong direct sound component and some very strong early reflections. And the other factor is when you put a speaker in a room, depending on where you put it and the dimensions of the room, you're going to be exciting room modes, natural room modes, and that can accentuate the bass. And yet none of these current standards include a bass boost. So we believe that if you calibrated headphones to these current standards, it's going to sound thin in the bass and too bright. So we went into our reference room and we did some measurements at the listening location, and the goal here was to try to replicate at the listener's eardrum the same transfer function measured using an accurate loudspeaker. And the rationale behind that is that when recordings are made for consumers, they're typically made through loudspeakers in a small room. So if you take those recordings optimized for speakers in a room and play them through headphones, they're not going to sound right unless you try to replicate the conditions under which the recording was made. So we went into our room and we did exactly that, and that became the basis of our target function. And we then did some subjective experiments where we compared that room-based target to current standards based on the diffuse and free field. And we selected two different targets, one that had slightly more bass and treble and one that was a little less bass and treble. That was target 2. And we tested this. We did 2 separate tests using an inexpensive headphone and a very highly regarded expensive headphone. And we had listeners rate these different targets. So we're basically taking a headphone, calibrating it, and equalizing it to different targets. And from that, we basically found the subjective evidence that this new target was preferred over current targets in the standards. And this was also true with our second headphone. So this became the new target that we wanted to do more tests with. So at this point, we basically empirically came up with this, and we wanted to sort of fine-tune it. And at the same time, we wanted to show whether the target response preferred for a headphone is similar to the target preferred for a loudspeaker. So we went back into our room and we calibrated our loudspeaker system. We equalized it to a flat response. So that was the baseline performance for the speaker. And we then did the same with the headphone, and we calibrated it so it had the same response as the loudspeaker in the room. And we did this set of experiments where we would have listeners individually adjust the bass and the treble to their preferred taste. And they could do this in quarter dB increments over a range of about 20 dB. And we simply took the average based on 9 repeats of this exercise using different programs. And if you ever do these types of experiments, these are great controllers. They're USB controllers. They don't have any start or end points, so there's no positional bias when they're adjusting these knobs. And we used a small sample of 11 listeners. Some of them were trained, most of them were trained, 3 of them were untrained. We selected programs that had lots of bass and lots of treble. So, and as I said, they did 9 repeats. So we wanted to get a measure of how consistent they were. So what did we find? We found that on average, when you average across all the listeners and all the programs, the headphone, they adjusted the bass about 2 dB lower than what they adjusted for the loudspeaker in the room. And the treble was also turned down about 2 dB. But what we found that people generally like to increase the bass for both the headphone and the loudspeaker within 2 dB of each other. So that became the basis, based on these method of adjustment tests, for our new headphone target. And we believe that this is an improvement on the current standards, and I think if this standard was adopted, I think the quality of headphones would be greatly improved. But before you can have a standard, it would be ideal if you can test it with a lot of listeners to make sure it's going to be accepted. So the most recent paper, we have tested this with 238 listeners. And so we took this, we basically had people compare four different targets, this new target, and we compared it against 2 headphones that are highly regarded. If you look through headphone review sites, these are very highly regarded headphones. And then we included the Beats headphone, which is, I think, the biggest selling headphone right now. And the question is this headphone popular because of its sound, or is it because of other factors like the marketing, the celebrity endorsements, and the coolness? So in order to remove these non-sound factors, we had to come up with a method to basically virtualize the headphones so that the listener's not aware of how it looks, what brand it is. And we call this a virtual listening test method. And we've done a lot of research to validate it to make sure we get similar results using this virtual method as if we actually were able to do a blind test on the actual headphone. And the correlation between virtual and actual results, using the actual headphones, about 0.86. And just briefly, this is how we do it. We measure the different headphones on a device, a measurement device at the eardrum, and we design filters to basically mimic its measured response. So we're basically simulating only the linear portion. And then we can play back those filters through a set of through a replicator headphone or a simulator headphone, and with a push of a button, you can compare different headphones, different virtual headphones. And here are the acoustic measurements of the actual versus virtual headphone for those 4 different headphones. And you can see there's very good agreement between the actual headphone and the real headphone. And you can also see that there are differences in the response, the shape of the response between these 4 different headphones. So you would expect that they would sound different. And these tests were done in 4 different countries. And a lot of these, this is not a, we didn't hire marketing firms to recruit these people. This was basically me traveling as the EAS president to different countries and giving talks. And in the process, I would carry iPads with me and do these tests. Some of them at Harman sites, some of them off-site. And we did a total of 238 listeners, They included trained listeners, untrained listeners, a lot of young people. The average age, the median age was about 29 years. And we also had people self-assess their listening experience. So they had to tell us whether they had no experience, a little experience, a medium amount, or a lot of listening experience. And to do these tests, we used 3 different programs, hip-hop, male, female vocal. And to administer the tests and make sure they're blind and carefully controlled, we developed this iPad application, test software application, that randomizes the programs, the order of the headphones, and collects all the preference ratings. So the results, basically we found that, oops, sorry. Okay. So if you look at the ANOVA, this is a repeated measures ANOVA, and you look at the factors that contributed to preference, we found experience had a small effect. Headphone was by far the largest factor. And then there was an interaction between headphone and experience. And I'll just focus on these main factors. So averaged across all these listeners, we found a strong preference for HP1 over HP3 and HP4. So clearly there's a large effect in sound quality between these 4 headphones. Looking at the influence between experience and headphone preference, we found that experience had very little influence. Whether the listener had no prior experience, a little, a lot, or a medium amount, generally they preferred the same headphones. So this was very encouraging that we don't have to design headphones for different levels of experience. People will recognize a good headphone when they hear it. The next graph, I'm going to show you first the preferences of trained listeners from different Harman locations. So these are locations where we have a training program. And all these listeners also have normal hearing, which is something we require. So here are the results from listeners in Farmington Hills, Michigan, listeners from Northridge, where I work, listeners from Harman, Germany, and listeners from China. So again, you can clearly see that there's good consensus among these different locations, even though these are different countries. So again, no evidence of any cultural influence. Now you could argue that maybe these are all trained listeners, so they've been trained to like a certain type of sound. So the next graph shows untrained listeners from different groups from the US, from Germany, from California, Citrus College, and as well as Canadian college students. And again, although there's more scatter and noise in the data, there's a clear trend that these untrained listeners like the same headphones as the trained listeners. Just looking at which country these people came from, we found that there was a small effect, and there was an interaction between the country and the headphone. So, whoops, I apologize, my computer is in some kind of, there seems to be some lag. Okay, so this graph shows that there's a very small effect depending on the country of the listener, how they rated the headphones on average. And in general, the Canadian and the Chinese listeners used higher ratings. And I don't know if it's because I'm a Canadian. We tend to be very forgiving and very polite, so maybe we don't like to use low ratings. It could also be related to the experience, because as I showed earlier, the more experience you have as a listener, the lower you tend to rate things. You're a little more discriminating. But the effect is very small. If you look at the effective country of the listener on headphone preference, there's very little effect at all. In fact, the overall rank order is consistent across countries for these headphones. Looking at age, unfortunately, we didn't have a balanced sample across different age groups, but if you look at the ages, the percentage of listeners in each of these age categories, they have resonances, and again, the less neutral, less accurate headphones had lower ratings. So, what's that? 1 minute. So the conclusions are, we found no preference influenced by age, listening experience, or where you lived. And the less experienced listeners tended to give higher and less discriminating ratings. So just to summarize what I've talked about, I've talked about loudspeaker research, headphone research, and preference for audio formats. And so far, the news is really good. Whether people are old, young, experienced, they generally, when given the opportunity, they prefer the more accurate sound. And the future, how can we move towards better sound quality? What are the solutions? I think more meaningful speaker and headphone specifications would clearly help, so that consumers, they can look at specifications and compare across brands and models and know which ones are the good ones. The science is there to do that right now, but the companies are very slow in adopting these specifications. And and the other key thing is that the same standards have to be applied for where the art is made in the professional industry as well as the consumer, so that if you have a similar speaker or headphone that's used in both communities, then you're going to hear what the artist intended. And I also think this issue of MP3 and low quality is going to go away as we get higher bandwidth and increased storage. Also, there's a real trend in our industry right now towards immersive sound, 3D sounds. It's starting out in theaters, but I think it may happen in consumer spaces as well. Some positive signs, we can see that lossless audio streaming services are starting to come online. There's an interest in high-resolution audio, which is better than CD quality. And I'm seeing standards activity in SMPTE, our film industry. They're working on better standards in the playback chain. And I'm starting to see more and more research papers being presented in headphones as well as loudspeakers. And that's my talk. Thank you very much. Do we have any questions?
Yeah, I think we may have run out of time, and I apologize, Dr. Olive, because we started late. It's not your fault, but certainly we hope that if you can stay a few minutes, people might come up to you. Your talk was like drinking from a fire hose, and I'm sure there's a huge number of questions queued up.
Okay, I'd be happy to answer questions.
Certainly, it's a very good talk. Thank you. Please feel free to talk to Sean. He will be around here for a while. And on behalf of Consumer Electronics Society and ICC committee, we thank you very much for the very interesting speech. And here is a small thank you plaque.